Two tropical systems, same ocean, only one becomes a Category 5 in 48 hours. Can you spot which? In the next few minutes, you'll learn the 5 rules that decide whether a storm explodes or fizzles. Stick around. At the end, we'll score a real system with a simple hurricane recipe checklist. If you live anywhere touched by the Atlantic, Pacific, or Indian Ocean, or you just love weather, you'll be able to read forecasts smarter and spot when a harmless cluster of thunderstorms is primed to ramp up. Every hurricane starts with a disturbance, a cluster of thunderstorms tied to a surface low, a wave in the trade winds, or any patch of disturbed weather. Think of it as the spark that organizes scattered thunderstorms into a single, breathing system. Hurricanes are ocean-powered heat engines. Below 26 degrees Celsius, deep convection struggles. Above it, the ocean freely feeds towering thunderstorms. That's why storms often weaken approaching Hawaii or Southern California. The Eastern Pacific's cooler waters starve them. To develop a closed circulation, the storm needs the planet's spin, or the Coriolis effect, to tug those winds into a swirl. Right along the equator, that effect is effectively zero. Move about 5 degrees north or south of the equator, and storms can finally organize and rotate. I'll unpack Coriolis deeper in a future video. Make sure you hit subscribe so you don't miss it. As moist air spirals inward and rises, it must escape at the top. Healthy outflow acts like a clear chimney. Exhaust moves away. Pressure at the core falls, and the storm can keep pulling in fresh, warm, humid air from the surface. Plug the chimney no matter how warm the water, and intensification stalls. Wind shear is how much wind changes with height. Many land thunderstorms like shear. Hurricanes hate it. Strong shear tilts and ventilates the core, drags in dry air, and rips apart that heat engine that they're building. For hurricanes, low shear is king. Mother Nature rarely lines up all 5 at once. Maybe the ocean's hot, but outflow is weak. Maybe outflow is great, but shear spikes. Or the atmosphere is perfect, but the water is a degree too cool. That's why truly extreme hurricanes are uncommon. The recipe has to snap into place. To predict intensity, meteorologists diagnosed the starting state, cloud structure, ocean heat content, surface circulation, upper level winds, and shear. Then forecast how each will evolve. The interplay is complex, and it changes hour by hour. Now back to our two systems. System A checks 4 out of 5, but has too much wind shear, so it struggles. System B nails all 5, including a gorgeous outflow channel aloft. That's the one rocketing to major hurricane status. So your hurricane recipe is, number 1, a tropical disturbance. Number 2, warm water greater than or equal to 26 degrees Celsius. Number 3, greater than or equal to 5 degrees from the equator. Number 4, strong upper level outflow. And number 5, low vertical wind shear. When the scoreboard lights up, expect trouble. In a follow-up, we'll forecast like pros, channeling our inner Dr. Strange to juggle changing variables and probabilities across a range of future outcomes. If that sounds fun, hit subscribe and drop a comment telling me which ingredient you think is most often overlooked.